Hi, I'm Ray Roberge, WA1CYB, and I'm going to give you an extremely brief talk on another software-defined radio. This is more fundamental than what Les talked about. This card that I just designed and is currently in manufacture right now. It's in assembly. It should be ready in early February. Unfortunately, delayed because of the Chinese New Year, but it's very similar to the cards that Les has, except the AirSpy typically concentrates on the lower frequencies. So one of the problems with having an SDR in space, which is what I'm talking about, AMSAT, and over here I have what the abbreviations are because people always ask what AMSAT is, and Ascent is the kind of like the R&D development side for AMSAT. So if somebody is thinking about a new something, whatever it is, they'll go to the Ascent people in charge, the Vice President of Engineering for AMSAT, and they'll ask, is this worth looking into, and can I have some money if you need it? For parts or whatever, and they're pretty good about it. And that's what Ascent is. The other abbreviation I might talk about is Golf, which is the name of the next series of satellites for AMSAT. It stands for Greater Orbit, Larger Footprint. The idea is you want the satellite up there higher so it illuminates more of the Earth. And Golf T is actually the next satellite that should be launched by AMSAT, and there's no official date, so I'll say I don't know, early next year, something like that. And it actually will fly an SDR. So I have a commercial SDR on that one. It's an EDIS SDR. It's about 4 times bigger than the one Les showed, and it does a lot of fancy stuff. It has Ethernet connection. It has USB ports. A lot of stuff that isn't going to be used in space, but also has, for instance, 30-something filters. Because unlike the AirSpy, it has a limited number of filters. It does have filters inside, but it's kind of limited. So if you really want to get up in frequency and cover a lot of bandwidth, you need a lot of filters in order to be legal, really. Otherwise, it's just an experiment. Which is also fun. I've done that too without them. So, I digress. So, back here, what is this? This is called Plan B, because Plan A is the next one that's going to be launched. So, I'm putting in the EDIS SDR. That's the current one that's going into the technical evaluation, engineering evaluation. That's what the T stands for. So it'll be going into that one. So that's Plan A. If we had this, we would use this because that is not standard for a CubeSat. A CubeSat is typically 92 millimeters by 92 millimeters. So kind of like 3 inches by 3 inches, that type of thing. And an E310 is this. So it's kind of like shoehorning it into a satellite, which makes the mechanical guys not happy. This hopefully will be the next one in the Golf series. Actually, probably Golf 1 or maybe Golf 2 will have this as an SDR as opposed to it. Now, let's talk about all the good things that SDRs can do. And this certainly could do that. It covers all the frequencies from 2 meters to C-band, 6 gigs. So you can enable VHF, UHF, 900L, S-band. You can do cross repeaters, all that. Waveforms. I've had 50 different scenarios, if you will. You can think of it as spectrum allocation of the satellite. So I could do simultaneous FM, AM, FT8. I can do a sort of a GPS type waveform, so you could do positioning. So I tried all those out, but typically, hams would just like a transponder, sort of like a repeater. So that's probably what I'll go with programming in here. Although some of the other programs will be in here and it's simply selectable. So, and we also have a downlink. I made it capable of 1 megasample per second. Typical downlink is 9600 baud, so pretty slow. So when you get data from a satellite, it's almost like an old telephone call. Sufficient if you're just monitoring temperature and everything. But if you want a picture and you want to download it, 9600 takes a long time, even with slow scan TV. So it takes a long time. This way, you have an image just like that, and you're on to the next image. So you could download pictures of stars and stuff like that. The reason I say that, that's one of the ways that a satellite knows where it is. It goes out and looks at the star patterns and lines them up, and so it knows where it is in space. Again, one of the other things about this board is designed in KiCad, which is an open source PC design tool, and it will be published on GitHub, after it works, I hope, but we'll see. Like I said, the breadboard, I'll call this the breadboard, will be next month, and probably certainly before the exposition, I'll have the next version of this, and hopefully that will be fully working one after I find all the mistakes that are on here. But anyway, the board basically can have a bandwidth of this board will have a bandwidth of up to 20 megahertz. So you could essentially listen to all of 2 meters all at once, or 20 megahertz slice of 432 if you want it. The current configuration is one of these bands will be received, and the downlink is at X band. So the output of this goes into essentially a mixer and an LO and a solid state power amplifier, and goes to an X band antenna. So it was originally started as what was called a 5 and dime, 5 gigahertz up, 10 gigahertz down. Although really it does all these others. We also have planned to do simultaneous coverage, where somebody can uplink at VHF, and normally the satellite will downlink at UHF on another board. This will pick it up and then downlink it also on X band. So if you wanted to see how good your system is, you can track it on 432, and at the same time have an X band antenna and see how your performance is. So there's a lot of combinations and stuff that you can do with an SDR. It's quite flexible, and yes, it can do JT8 and those other modes too. I've checked it out with narrow band and wider band FM, CW, RIDI, telemetry, different kinds, phase shift coding, and that's what I've been doing. Skip asked me last time if I'd talk at the convention, so you'll see a similar thing to this at the convention, except 45 minutes worth. And maybe I probably will bring some boards along with me, probably the breadboard, if I'm on to the next version, and probably have a demo of waveforms on the ground anyway. And I have demonstrated this at an AMSAT convention a few years back also, so very, very feasible to do. Any questions?
Ray,
Bruce.
for the new hams in the room, and there's quite a number of them. Ray, for the new hams in the room, and there's quite a number of them, can you explain to them quickly what AMSAT as an organization is, and just a little bit about its history, its purpose, that kind of thing?
Sure. AMSAT, Amateur Radio Satellite Corporation, is as its name says. So its goal is to put satellites in space and have amateurs use it. Currently, there are several up there operating. I'd say there's probably a good dozen in the world. On the U.S. side, I think there's only one operational now. And there's also one satellite that's actually in synchronous orbit, so GEO. Unfortunately, not for the U.S. It's called Oscar 100. The satellite series is called Oscar, and they're up 100, and they operate all the time with S-band up, S-band up and X-band down. Yeah. Yes, Qatar funded it because it's actually part of their communication satellite. So they're piggybacking on it. And so, they have power. So they're using their solar cells, their battery, and they only had to have the transceiver and the antenna. And even then, Qatar had an engineering organization actually design the stuff. They wouldn't let the hams do it. The hams got to review it and make comments and changes, but it's that kind of a thing. When you go on a commercial satellite, it's very, very controlled. So we've had a lot of satellites over the years piggyback on other missions, NASA missions typically, and usually NASA gives AMSAT a free ride, except to pay for the expenses of the integration, which can be $200,000 or $300,000.
It seems that geosynchronous is uncommon in the amateur radio community. What are the reasons for that?
Money.
It's all
money.
Right.
Oh yeah. Launch it in LEO, low Earth orbit. Let's say below 500 kilometers is pretty inexpensive. It can go up to like 800, pretty inexpensive. But there are rules now that kind of limit you to 500. If you go above that, above 800, the Van Allen belt starts at around 1,100 kilometers, which is pretty difficult. And so there's two of those, and there's a region where GPS is, and then way up is GEO, right? Far, it takes a lot of energy to put it up there, a lot of money. We had connections in NASA a long time ago, and various organizations like Lockheed, that we'd get a free ride, even up to GEO. Not so anymore. So it costs a lot of money. Not $1 million, more like a double digit.
And the other thing is that GEO is tightly controlled, and countries will get a slot, where to put their satellite. And so it's not like like Musk launching satellites in low Earth orbit. You have to go to the UN, and there's money involved, and people trading licenses and all kinds of crazy stuff going on. Yes.
Yeah, but even Musk has to get permission, his orbits. So he's not the only one. There are actually 4 different organizations that do the same thing as Musk. You only hear about him. So.
Any other questions for Ray?
12-layer board, by the way. Always want volunteers, digital, whatever, RF, let me know.
How many members on your team, or is this just you?
Well, right now, it is just me. My software guy got pulled to work on, to finishing up a golf tee effort on software. They were in trouble. So it's just me. So, okay, thanks.